Good afternoon, everyone. I kindly remind that the session will commence in 8 minutes.
Kedengaran tadi.
Good afternoon, distinguished guests, respected lecturers, honorable speakers, and all participants of the 7th Summer Course Program with the theme Exploring Indonesian Community Service, Tourism, and Agriculture. On behalf of the Faculty of Animal and Agricultural Sciences, it is my great pleasure to welcome you to the fourth day of our program. My name is Yankin Koyima, and I will be your Master of Ceremony for today's session. Before we begin, I kindly remind all participants to fill out the attendance form provided in the chat section using virtual background during every session and change your Zoom username according to the instructions. Please make sure to complete it as soon as possible so we can record your participation properly. Let us express our gratitude for the opportunity to gather here and continue our journey of learning and collaboration. Now, it is my honor to introduce our distinguished speaker, Ms. Kinanti Mondilaksita, PhD, from Norwegian Mycelium, and today she will share insight on mycelium as the future of protein, a sustainable solution to global food security. In this session, we would like to invite Dr. Rafli Zulfa Kamil, a lecturer from Food Technology Study Program di Diponegoro University, to moderate this session. Before we begin our session today, we kindly invite everyone to turn on their cameras to take a documentation today's event, and don't forget to give us your brightest smile. Okay, I'll wait a few seconds to ensure everyone is ready. Please take a moment to prepare yourself. Kindly turn on your cameras and don't forget to set up your virtual background. Okay, are you guys ready for the documentation today? Okay, I think you all is ready. And let's hold the pause for a few seconds, and there is 3 slides while our committee takes the screenshot. Okay, I'll counting down. Let's start with the first slide okay, in 3, 2, 1, smile. Okay, next slides in 3, 2, 1. Okay, for the last capture, ready in 3, 2, 1. Okay, done. Okay, thank you everyone. Now we've captured the spirit of today's summer course forever. Okay, now please welcome Dr. Rafli Zulfa Kamil. We kindly invite you to be a moderator on this session and guide us through the main lecture and discussion. Okay, without any further ado, I hand over the session to our moderator, Dr. Rafli Zulfa Kamil.
Okay, thank you for the Master of Ceremony. So, good afternoon, ladies and gentlemen, distinguished guests, respected speakers, and dear participants. Once again, welcome to the 7th Summer Course Program, proudly hosted by the Department of Agriculture, Universitas Diponegoro, with the theme Exploring Indonesian Community Service, Tourism, and Agriculture. And it's an honor for me to serve as your moderator for today's session. And my name is Rafi Zulfa Kamil, as our Master of Ceremony said, and I'm one of the lecturers from Food Technology Department in Universitas Diponegoro. And in this session, we are delighted to welcome a very special speaker, Dr. Kinanti Mondilaksita from Norwegian Mycelium, and she will share with us a fascinating topic titled Mycelium as the Future of Protein, a Sustainable Solution to Global Food Security. Before that, I would like to read at glance Dr. Kinanti CV. So Dr. Kinanti Laksita, dedicated food scientist, currently working at Norwegian Mycelium in Oslo, Norway. Dr. Kinanti holds a PhD in food science from Universitas Gadjah Mada, with part of her doctoral research conducted at the University of Borås, Sweden. Her academic background also includes a master's in estate crop technology and bachelor's degree in food and agricultural product technology, both from Universitas Gadjah Mada. And also her expertise lies in sustainable food innovation, particularly in using fungi and mycelium as alternative sources of protein. At Norwegian Mycelium, she focused on research and development to support the future of food sustainability through biotechnology, fermentation, and process design. And she also has experience in food safety, emergency food development, and has been actively involved in community-based sustainable agricultural programs in both Indonesia and Japan. And today, Dr. Kinanti will guide us through how fungi-based protein can contribute to sustainable food system, reduce environmental footprints, and serve as a promising alternative protein. So, for Dr. Kinanti, are you ready with your topic to deliver to us?
Yes, I'm ready. Thank you so much.
So, okay. So, without any further ado, Dr. Kinanti, the screen is yours.
Uh, thank you. I'll share my presentation. Okay. Can you guys see my screen?
It's all set. You can go.
Yeah. Okay, thank you. Just wait. Just close it, I guess. Okay, so okay, so I guess it's a good afternoon there in Indonesia. Is actually still 8 a.m. here. I would like to say welcome to everyone from the 7th Summer Course Program 2025. I'm actually a research scientist in a company from Norwegian Mycelium. And I am very appreciating that today I have the chance to share to you what is our company and what we are currently working with. So a brief introduction to Norwegian Mycelium. We are a fermentation technology company which transform food industry side streams, or we can also call it byproduct, into high-value ingredients using the power of fungi, as we mentioned before. So there are two keywords here, myceliums and fungi, which I will further explain on what is that. First thing first, we are using fungi because it has a set of versatile enzyme. So naturally, it also have a broader range of substrate that it can use to grow and produce biomass. In our case, since we are using side streams, which is can containing broad range of nutrients, we naturally choose fungi. And on top of that, actually, fungi can make a thread-like structure, which we call a mycelium. It is actually like a root in a plant. It is actually the transport of nutrients, so it's transport network. Then inherently, it's very packed in nutrients, notably proteins. It has then a potential to be used as alternative protein. So to give you some example on myceliums, I guess we are all familiar with tempeh. So we start with the inoculum or starter of a tempeh that is in a form of powder. Is actually some spores or hyphae of the fungi. in this stage, it's still like a microstructure of it. It's less visible to the eyes. And then when you inoculate it into pre-treated treated soybeans or cooked soybeans, then inoculate it and incubate it for some times, then you will notice that slowly this, as shown in the picture, if you see my cursor, so there is this whitish network that connect the soybean to each other. So it is actually what we call it a mycelium. So, and what is actually the driving force of our company? It is actually the global problem on how we actually will produce 60 more food for people in 2050, but in sustainable manner. As we know that 90% of all deforestation driven by agriculture, that entails that we will have less of land expansion in the future. And in fact, 33% of food itself is lost or wasted instead of being used or eaten. And we also have, in addition, 70% of all fresh water is also used by the agriculture. So the idea of NOMI is by using these side streams, which if we are not utilized well, might be end up as waste. From the food industry, we use it as a substrate to grow filamentous fungal biomass that I've explained about mycelium, which inherently contain high protein that hopefully or potentially we will use it as a food. And on top of that, we can also use it as a feed, notably for aquaculture, which is very big in Norway. And the example is salmon or rainbow trout. So there is the idea of our company. And that idea is, of course, we want to support to build a circularity in the food system and also to help with the resilience of food systems. And our solution is through fungal biomass fermentation. With first, we are using submerged stage fermentation. So it is using a liquid fermentation. And why we are using that? First thing first is because it's a well-established industrial technology that proven can be scaled up to thousands of tons, basically. And it is also proven to be efficient. If the process is continuous, it can run for 24/7 production, and it's only taking a small land footprint. As you can see the picture here of the bioreactor that actually in a fungal case, we will explain later, but basically we can scale up vertically and it's also better for the fungal itself instead of using expanding the land horizontally. And then it also have a relatively low carbon print, can be lower than 3 kilogram carbon dioxide equivalent per kilogram of product produced. Another point is, since it is sustainable, is using a better resource utilization by using the byproduct or side streams as low-cost inputs. And the second, we already mentioned about the land, but this have less competition with the agricultural land. And lastly, it is also actually flexible, meaning it can be deployed in various type of settings on the existing infrastructure of food industry. For instance, we can also do a co-location with the company that producing the side stream. And on top of that, we also build on partnership, then they can basically tailor the inputs to the best given market. And meet our teams here from NOMI. As you can see, actually, we are a very diverse team. We have 11 nationalities, but not only the culture that is diverse, we also have a quite diverse expertise across applied fungal science, data-driven innovations, fermentation scale-up, and relevant industry expertise. For instance, in my case is food science, and my colleague is from feed science. In addition, we also have some fermentations technicians, as well as an intern for now, which they are also greatly contributes to our research and development and innovation program. Another things that were to mention, we have exceptional traction with the partners in both Europe and Japan. Our goal or pathway is to commercially deploy our technology as soon as next year in 2026. In Norway, we have major research collaboration through grants, mainly R&D and also scale-up work with the research institution in Norway. It's SINTEF and NORSE. As well as in Norway and France, we have commercial contracts for the development and deployment of both our process concept and also the end product solution. In Japan, we have commercial development contracts and major strategic partnership for scale up, research and development, and they are also our main side stream provider. It is Nitten, a sugar beet company in Hokkaido. And we take a look deeper to our process. By the way, in the middle of the presentation, if just interrupt me if you feel I'm explaining too fast or something is not clear, or we can have a session of question and answer part in a part of the section. That's also, just let me know. So our process, first, I want to give an example on the feed case in this one. So this is the high level, meaning like a zoom out diagram of our process in fermentation. First, we have these side streams in pink or upon the reception. And then after side stream is received, we cannot actually use it directly, in which we need to formulate it to meet the requirement of nutrients for the fungal fermentation. And this formulation step is actually we put a lot of research and effort on this part. So this is part of research and development activity. At the same time, we have the fungi, the seed training here. For the seed training, we also have a different research and development there, meaning that we carefully select the strain that is matched to our side stream and our product specification, and it will go through a seed training to be able to be used efficiently in the main cultivation. Then we have the side stream and we have the fungi, and then we basically start our main cultivation, which actually the core or our process where we put a lot of work in here, mainly for optimizing the process itself and also to design the process mode, for instance, continuous or cyclic batch or the etc. So after the main cultivation, when the fungi is actually fungal biomass is meeting both requirements for quantity and quality, it will go through the step of inactivation using heat treatment, and then we separate them from their spent medium, or from the liquid, basically from their medium. And this liquid naturally, since fungi is taking up all the almost efficiently the nutrients that is available on the side stream, then the side stream is having a decrease in chemical oxygen demand. Basically, the can be organic matters or the solid that is inside the side stream. It will ease the process of wastewater treatment afterwards. And as for the fungal biomass itself, it in the feed case, it will go through drying, product drying, and then to go through product milling to shape it into the final product. So this is our feed case. Then I will continue to the food case. More or less, actually, the main cultivation and the R&D work are not so different from the feed case. However, there are two main distinguishable points on this. The first one is we should make sure that our process meet the food grade or compliance to food manufacturing standard. And the second, here in the downstream processing, actually, I wonder if you can see my pointer. Maybe I should just, okay. Second. So here, in the further downstream processing in the food case, actually it is not very set like in the feed case, because we need to tailor it based on what type of food product that we are aiming. For example, if we want a wet product, then we don't carry on with the drying and so on. But if we want to texturize it, we put extruder. Or if we want to make a powder, then it's more or less following what is we have been doing for the feed case. Next. So I have mentioned a lot about these side streams or byproducts of the food industrial food in the factory. So what is actually side streams? I will explain, and why do we choose them as the substrate for our fermentation, as well as what is the challenge that is coming with it if we want to use it as our substrate. So we said at the beginning that we are using submerged fermentation, which means that we are using a liquid type of side stream for our fermentation. It's not like making a tempeh, but the fungal biomass is, let's say, like swimming inside the liquid and growing in there. The example of side stream on the picture that you can see, it can be like the washing water from the processing of vegetables, beans, or in Norway, we have a lot of this fish processing waste water. And also it can be the byproduct from cheese making, for instance, acid way or sweet way, or permeate from ultrafiltration. And in case of side stream, actually why we choose it, because often like food or feed ingredients that is sorry, so the nutrients that having the grade of food or feed is often either dissolved or suspended in this water. It has enormous volumes, billions of liters per year globally. And we mentioned about nutrition is actually nutritious from both point of view of the microbe itself, and also it's actually for us it's kind of loss of nutrients that is retained on there. And so far it's having a low cost, almost free. And as for now, it is actually still underutilized, but there is a reason why it's underutilized. It also comes is related on the complexity and the challenge coming from it. So I will elaborate on what is the first challenge of the side stream. First, it has a composition complexity. It unlike when we are using a synthetic medium, you can't really formulate it in a pure manner. So it is already coming with the mix of nutrients, for instance, mono, D, and polysaccharides, and then the proteins, amino acids, any type of minerals, and even fatty acid. And the challenge number 2 is actually it has quite variability and seasonality. As you see on the picture here, that it's seasonal. It can go up and down in both quality and quantity, and it can be random in pattern. It can have a trend like going up, or what is the real observed pattern. What it means for us is, especially in the food and agricultural sectors, they are not consistent during the year. So their composition, volume, and quality actually can change based on the seasonal harvest cycles, raw material variability, and processing conditions, storage, and transport effects. And then why it is matter for us, because then it makes our standardization of process challenging, and consequently it affects our product quality, nutrients recovery, and process efficiency. And then it also requires quite adaptive processing, real-time monitoring, and flexible formulation of both of the side stream and our process. So for examples, the whey or sweet whey or acid whey from cheese production, it may vary in the content of protein and lactose content depending on the milk source, and also depending on the season. It can have the same source, but the season are different, and therefore it has different composition. This will impact both fermentation or our downstream processing. Then challenge number 3 is, though it's high in nutrients, but it's in the form of either dissolved or suspended liquid, and it has sometimes a low nutrient density, and it has some challenge in logistics. So this challenge is mostly also from the food industry, for food industry itself, because it has a lot of water, and it has then a short shelf life because it gets worse quite fast, and oftentimes is too dilute to justify its transport, because imagine like a big truck is really needed to transport it, and whether it's worth it or not. And the effort to concentrate it and preserve it is also hard to justify. But for now, the food industry, mainly in Norway, just see it as quite a burden or something that they need to discard immediately. Meanwhile, it's actually produced in high rates, and yeah, they need to basically dispose it. So that's why they are not putting much effort for now for this side stream. So it has value, but it also has the challenge. And then here where we are trying to build a partnership with this food industry. Basically, we envision to help them to reach the circularity of their system. And we need to convince them a bit. So, and I have elaborated what type of challenge that we have with the side streams. And then afterwards, I want to share to you what is our approach to those challenge. And here we are still developing and trying our best to basically to match up with this challenge. So it's also nice to discuss if you find something on this section. So I mentioned about the complexity of the size rim composition. And first approach is actually we are using infrared spectroscopy to help us to, is basically a tool to help us to adapt our fermentation strategy to each size stream, whether it is from different vendors or it is the same vendors, but since it has some fluctuality, then we need to map this out quite rapidly. And we are using this infrared spectroscopy. So the spectroscopy itself for infrared, we have wavelength around 800 nanometer to 500 micrometer. This light source will then we basically put it through our samples, and then our samples basically it is specific to molecule interaction. So in the sample, then the molecule bonds will have a different vibration that is will be detected and will be identified. So this vibration of the molecule is actually like a fingerprint of us. It's giving it identity, so of what it is. This the example for the spectra from Fourier transform infrared or spectroscopy. We call it FTIR. As you can see here, the color like in lipid, for instance, we have a specific spectrum that identify this is actually lipid and this protein and this nucleic acid. This is at the beginning, it's like a semi-quantitative method. But in our company, we are currently building a model in-house. So basically, since infrared spectroscopy allows us to analyzing like major dominant compounds in side stream, it's in order to help for us to make it work and to formulate our side stream faster. We build this model. We have some models ready, but we are also still currently developing some models for other substrates. We spent quite a lot of time and research and development in this one. Basically, all to help to facilitate our future handling of this first challenge. And why we are using infrared spectroscopy. Of course, there are several options that we also try to check. But in the end, for now, at least we come to this infrared spectroscopy because it is non-destructive, is ideal for continuous or real-time monitoring, and it's rapid real-time analysis. So it's suitable if we want to put it inline, inlines like when we are doing the fermentation or online, at line or offline measurement. So it's very flexible. We can put it in every line. Then it has strong points because it has multi-component detection. For instance, in HPLC, if we run in a sugar column and sugar system, then it will read sugar with limited amount of another compound depending on the method that we are using. But in spectroscopy, you can get all at once, like sugar, lipid, and proteins, basically. And so far, we don't need reagents or chemicals to use this. And consequently, it reduces our operational cost and also reducing our environmental impact. And there is things like highly repeatable and reliable, though this word is quite strong. But actually, the effort through it is quite a lot that we need to be very careful on building the model, and we need quality data, and we need to done it properly in order to achieve this reliable mode. And as mentioned before, support automation. And what we like is also is flexible across the sample type. It can be aqueous, liquid, or solid, for instance. Okay, then next. So there is our spectroscopy is like our front line of uh, helping us to tackle the challenge that come with the side stream itself. But then what's more to think actually before starting the cultivation? So the diagram might be too much, but it's actually it's entail the substrate preparation and inoculum preparation before entering the fermentation. Um, while the spectroscopy is doing a very nice way to reflect our composition of the side stream and the nutrients availability. However, oftentimes availability doesn't equal to the bioavailability of the nutrients there. And therefore, we need to think, do we actually need to supplement it with something, or do we need to actually carry it on with pre-treatment beforehand to make it more accessible to the fungi? So there is one thing. It's, and that entails to media supplementation. For example, in here, we can add some minerals if it's lacking, but we need to be very mindful in adding the media to add the supplementation, because then we are constrained by it should be saved because it's for food and feed first thing first, while it's also have a good compatibility with our fungi. And the last thing is the cost, because actually raw materials can contribute to 35 to 55% of our production cost. And the second is the inoculum of choice. Of course, we need to match that this fungi actually can use the substrate. What is the growth pattern? What is basically, we need to know deeply our inoculum in order to make us having like smoother operation in the main fermentation, and also to meet the final product quality. Okay. And there is before the fermentation, and then after the while ongoing fermentation is happening, like what could be the challenge there. So the first one is, of course, operational and conditioned mode. Naturally, some companies, including us, thinking that continuous fermentation would be ideal, because then it's sometimes or relatively always having a highest productivity of the fungal biomass that we have. But it's actually coming with another trade-off. For instance, then it needs quite a more skilled labor, and then it has more maintenance, it's taking more resources, and so on. And therefore, we need to put that into consideration. And also the fungal growth itself, whether it's actually better to just give them like cyclic batch or uh, fit batch fermentation if there is inhibitor and so on. And then bioreactor configuration, I think it's worth to mention because we are now dealing with non-conventional submerged fermentation, and I will explain why. Because as I mentioned before, we are using filamentous fungi that is having a macro structure. It's like the filaments that you can see by your eyes. It's often making our bioreactor struggling a bit if the design of the both bioreactor configuration and the process is not supporting it. So they're coming with challenge with this morphology actually, and therefore we need to play around with our bioreactor configuration. And aside from the fungal itself is of course from the side stream characteristic, because then it will give a different hydrodynamic in the fermentation, and it will affect how we transfer the oxygen, how we transfer the nutrients on the bioreactors. And of course, we have a constraint here, a challenge that we need to, what operation that we are applying or what process parameters we are using, it has the boundary that it still need to meet the product that is produced still to meet the palatability and nutritional value that we put specification on. So that is one thing. And then the process control is also very important. Either it's through some integrated sensor or modeling and so on. Then, so after the fungi is growing and then we are ready to harvest now. So in this step, like fermentation, harvesting, and then after that is the downstream processing. So in order to design this, how to recover the product, we need to put consideration in the first thing, like a process mode that we are applying. Imagine if we ferment it in a continuous manner, but our downstream processing is not really continue. So there will be like overflow of this fungal biomass. And therefore the approach is either we choose the downstream processing that actually can afford continuous mode, or we invest in another holding tank to make the transition smoother. And also the broad characteristic, for instance, if example is in drying, if we have a lot of sugar, is a drum drying actually working because it's a direct hit to the fungi and then it will burn it or so on. And then is freeze drying actually the best? How about the cost and so on? And we can basically put into consideration on that, which is actually now still ongoing research and development here. And then change in product quality and quantity. Of course, if the specification change, then not only sometimes we need to change the instruments, but we need to be very mindful on how to operate it in order to tweak it a bit to reach this quality and quantity that actually we desired. Another thing is about energy efficiency. Maybe it sounds nice to have, for instance, freeze drying, but is it actually feasible from the energy point of view? So that's of course one of the approach that we need to consider. And then the other thing is waste stream. Why is waste stream? So we are a company that is using, let's say, side streams of the food industry but also we still have a small amount of our waste stream, and this is can also be affected on how we design this uh, downstream processing. Will it make us to have more product loss and generate a new waste or not? So we should put it into minimum basically. The last thing is the challenge is, can we actually scale it? Is it scalable process? So how feasible would be to jump directly? This is our cute bioreactors. It's a bench scale from 2 or 4 liters. Can it jump directly to around 10 meter cubic of these big bioreactors? So the question is, so the answer for now is it can. However, what we need to point out is that from this, actually in the middle, we have a pilot scale from 40 to 100 liter or 200 liters. And in here, we are having we need to identify the main parameter for scale up. So it's mostly our bioengineers work. But to keep these parameters constant throughout the scale is quite important, and to see whether this is possible or not. And the second thing is, of course, the economic size and the design wise. So we normally have process simulation to simulate it. And we also carry on a techno-economic analysis. When we have the design from pilot scale, then we run this techno-economic analysis, whether it is actually feasible or not. If we run it in a bigger scale, is it to make us profitable or actually not? Or how about the energy, how about the mass balance is also normally in one simulation. So process simulation is playing a very big role on this. It's just like any other industry or pharma or something. And yeah, I have mentioned several stuff from it, the importance of our process simulation. It is for our research development, process design, product, even for product planning, which I will explain later, process optimization, operation, and then decision making. So our process simulation, it's built based on our empirical data collections, that a lot of empirical data collection. This actually allow us to then design, test, and refine our process virtually before we actually commit to a real physical resource, like buying the fermenter or something. In this case, we have, if we have process simulation, it can be like a safer way, or kind of like mitigation, build the confidence both of for us and also our partner company. For instance, in this way, like for Nomi and Nitan, if we want to carry out with this. And then what is actually the challenge here, and which models crucial for the process? So basically, again, based on our empirical data collection, then we try to map out what type of model that is actually describing or reflecting the best of our data, instead of try to push or fit some kind of model to our data. So it's, for now, it's quite the opposite. And yeah, I mentioned about the which model crucial for the project. Another challenge is, of course, from empirical data collection, we should have a very good quality data, meaning that it have less variability, conduct properly with a very reliable method, for instance, and so on. Okay. So all the talk about the process from the side stream to the production. Now it comes to a domain that actually I will give example on what is closer to my expertise, which is the food side. So we also want to mention both of the challenge and approach regarding this, which the example of meat replacer for now. First, I want to you to see in the this I would say it's a beautiful picture. This is actually our mycelium. We zoom in the microscope and we take a picture of it. So this is how it is in a microstructure. And then it's just make us realize that, okay, this is a macrostructure, but also still a microbes somehow. And therefore it has the challenge itself in here. So I will start from the safety and regulation. So we are still using fungi, filamentous fungi, that maybe it has a questionable grade on whether it is safe for food or not. We need to make an assessment whether this fungi or these strains that we are using is actually generally recognized as safe or GRAS. That means that it is fine to use it and eat it. That we need to assess. And the other thing is about its biosafety level. We need to make sure that, of course, it will not produce some mycotoxin or any other harmful compound. Another challenge comes from whether the strains is actually commonly eaten for sometimes or not. Because if it's not, then it is a novel food, it's a new food that entails more effort and work to basically submit it to, in our case, to EFSA. EFSA is European Food Safety Association. So we need to make sure that we submit this strain to them in order for them to approve that, okay, then this is novel food, but it's meeting all the criterion and therefore you can use it as a food. That's the main challenge from safety and regulation from the fungal itself. Another thing what to mention is that in Europe, for instance, they have a different type of regulation regarding the RNA content of the fungi, and therefore we need to also make sure that our process is reducing the RNA content of the fungi to a certain level. Another challenge is we are using side stream, and some it's also affects, it's kind of sometimes triggering the regulation people, like, oh, it is a waste, something like that. So this need to be communicated very well, and we need to have a good basically knowledge on it first thing first, and a good assessment on it. Actually, I will tell you that most of the time, this side stream from food industry, they were kept in the food grade. So it is grading as intended use for food still until it leaves the tank to wastewater treatment or so on. Then it become another grade. So most of the time it is food or feed grade or animal byproduct grade. And therefore, what we need to do is we keep this change of transfer and processing to ensure that it is still entering a food grade. But on the other hand, we also have a sterilization process we conduct prior to fungal fermentation to make a double ensure that there is no microbial activity afterwards, aside from the fungal that we are inoculating. The last one is from the process itself. We try to follow a good manufacturing good manufacturing practice, and apply HACCP to our process. So it's a whole assessment from system to product, chemical, instrument labs, and so on. This effort is usually the responsible of me as a food scientist, also with the people from the process itself, like bioengineers mostly and the technicians. Second challenge is since I mentioned about variability is actually also affecting our product. For now, in order to tackle this, aside from having FTIR to help us with process understanding and process control and design, me as a food scientist need a lot of interface and discussion with the bioengineers. First, we need to map out that we have very good knowledge on the clear input specification, meaning what is the input, what we put inside there, and how it is processed, and so on. So it will help the process designed for both upstream and downstream, and then help us also to build simulation just in case and have a better quality control. And then other than input, we also work a lot on the clear product specification. It's quite challenging, but more or less with this one, the fungal itself won't have a crazy variability compared to the side stream, since we formulate and design the process more like we treat it as our main product. So it's not we are careless because it's a waste product that we cannot control, basically. So that's coming from the fungi itself. Now, the challenge at the food product development when we already have the biomass, the fungal biomass here. So we have it after the harvest, and then this is example we are making not we making bular. So maybe in Indonesia it's called like bakso or meatballs from the fungi. So I will give this an examples of this case, just like another actually general way of developing product. I will just give a brief challenge specifically to this one, but more or less it's actually quite general. So first thing first is to meet the product specification. Of course, first thing first, we need to know first, like what is the characteristic of this biomass we are producing. We need to profile it in a very deep understanding manner, and also it should be have a clear specification in order for us to map out what is the next step, how to meet the specification of meatballs. So first thing first, again, understanding of our product is important through the profiling and instruments, or through sometimes sensory analysis. And the second thing is now we understand our product and how we want it to change. And then that demands the clear parameters or sensory attributes or specification of the target product, in this case, meatballs. What is like the key parameter or sensory attributes of meatballs? How we can call it meatballs, like what makes it called meatballs. So there are some aspects that we need to identify and list and study. So a lot of work is also carried on in this one. And based on these two understandings, then accordingly, we will design our process to meet the desired texture. For instance, the extruder, what type of extruder, and then how is the mode operation, how is the design of process. Again, it's another process in here. And then, of course, after we have it, we will have the test and evaluation. I would say at the beginning, maybe since our research is carried on in every 2 weeks, in the first stage, we will evaluate it in 2 weeks, but it's like a graph like this. After we reach stabilization, then it's just test per batch, or test, yeah, per batch is important, or if there is some issue and so on, then we need to do the evaluation. So this is product specification. The second thing is the market acceptance. So we have this other, not, yeah, I would say it's quite competitor that have been there for some times, but actually we are also quite grateful that they are already in the market. It's called corn. So it's also mycelium based food from UK. They are using Fusarium venetatum as their mycelium. So since there have been around, the people in Europe have quite a good acceptance to eat myceliums compared to, for instance, if they need to eat this insect or something like that. It depends on the location, but maybe people in Indonesia will have less resistance. It's just my hypothesis since we have been eating tempe oncom, for instance. But in Europe, they actually have been introduced this mycelium food towards corn. But it also entails that they actually have a quite standard from corn here on mycelium-based product. A good thing is we can use it as a base standard, or we can try to go beyond, but it's of course need to be evaluated. And again, taste can be a barrier basically. So we need to continuous R&D to refine our products and periodically doing the sensory evaluation. The last thing is about the correct and compliance labeling, because oftentimes we don't want to over label it. We don't want to put on the label on like some greenwashing or something. For instance, we also need to define what is the target product place replacement. In this case, is meatballs. We need to clearly define this is vegan meatballs from fungi or something like that to make their perception is better and to communicate basically our product to the consumer. And also this entails about the carbon footprint labeling. When we put our carbon footprint, well, of course, we need to make sure that we are certified enough with ISO that we are allowed to put that. Otherwise, we need to use the third party that is certified to do the life cycle assessment to define our carbon footprint. Okay, sorry. And the last one is about product stability. Just like in other products, we need to ensure that nutritional and sensory attributes are still hold true for a dimension of times. Again, it's through the test itself, quality control, validation, and through sensory analysis and instrumental measure. We need to make sure that for sensory analysis that it is still safe. That is first thing first, because we will use human to evaluate. And like other type of food, I also need to test the shelf life, like with real-time analysis or accelerated test for control. Okay, that is things. Also, I talk a lot about our process, but I will just add one additional things. If you notice, actually, in the when I explain about our team, I also mentioned about intern. So yeah, we have quite several interns in our company, and we are quite open about it. I will tell you about the detail. So the internship at NOMI, we have the duration. First thing first, I would like to mention that in our intern, you get paid like the other worker. And then the duration for this internship is at least 3 months, because in order to make a meaningful impact on both NOMI and you as an intern, we need to build a project that is at least 3 months. The second thing is for the study background and major. Of course, if it's closer to our expertise on the like hotspot that I mentioned about research and development, it would be nice. But otherwise, it's super nice to become an addition of expertise to our team. So feel free to contact. If you're interested, you can contact us in careers@nomi.no, or you can contact me directly through kin@nomi.no. And I will also invite you to check our website at nomi.no. Okay, so that's the end of my presentation. Question, comment, and feedback are very welcome. And tusen takk is thank you in the Norwegian.
Okay, thank you very much, Dr. Kinanti, for such an insightful and inspiring presentations. Now we are moving to the Q&A session. So if you have any question for all the participants, please feel free to raise your hands and or type your question in the chat box. Maybe we already have one question, Dr. Kinanti, from Ahmad Ali. So for Ahmad Ali, please, can you also open your cam to have a nice discussion with our speakers? I will help you with the question. So Ahmad Ali have a question. Ma'am, can you explain the graph of spectroscopy again, please? So maybe we can look back.
Sure thing.
So,
Okay, so this one, yes, this graph. So basically, the principle of this spectroscopy is to basically give a vibration move on the molecule interaction of or the bond of the molecule, not the molecule interaction, but the bonds. As I mentioned, this actually first thing first. I would admit that I'm not the expert on this one, but I will try to explain it in the broader way. So this unique bond-to-bond interaction then will give some peak in a certain area. So for instance, this bond will give you peak on this area, or this bond CO will give some peak on this area and so on. So this peak, and then based on our library, we can identify on this peak whether it is correspondent to lipid protein, because for instance, this typical of bond can be unique to a typical molecule. So we can map out through the library, this bond is usually from nucleic acid, for instance. So this is what the spectral about. So each number will give a unique wave number, which is the x-axis here, and will give a certain absorbance based on how strong or how is the intensity of this bond that is present. Would that be clear enough?
is it already clear, Ahmad Ali, with your questions? So maybe it's basically infrared spectroscopy can help us to see whether in the what you call it side stream, whether the composition is contain lipid, protein, and nucleic acid, or another component with the specific bond, right, Dr. Kinanti?
Yep, exactly.
Yeah, maybe
So
as simple as like that.
mhm.
So we can move to another question. Maybe I give the chance from the participant who raised their hands. Sarah Salihu, do you wanna deliver your question directly or by typing in the chat box?
I found one question in chat box.
Yes, I have a question.
Yeah, it's your time to deliver your question.
Okay, can I ahead? Okay, the chat box. Can I go ahead?
Oh, you already sent the question.
Can you hear
in the chat
me?
box.
Okay, chat box. Thank you. I was on the chat box.
Okay, sorry, because your sound is not can hear clearly, so maybe you can type your question in on the chat box. Move to another question from. Wait, there's something trouble with my laptop. Aurelino, do you wanna deliver your question directly or by chatting in the chat box?
Yes, sir.
Yeah, okay. Please deliver your questions. It's your time.
Okay, so I think I just wanna ask about related into Indonesian condition because this product hasn't widely known in Indonesia, and actually I know this kind of product like a microprotein type of based product is just from since few months ago only, and
Mhm.
I just want to ask, will it be so will it be the right solution and could be the like crucial solution in order to tackle the food security issue in Indonesia, or will it be so potential, and especially regarding to the protein based product. Yeah, thank you.
So I could directly answer for that. I think judging from the amount of the food industry in Indonesia and as well as the liquid substrate that's available, I think Indonesia is actually quite a market there. Is quite promising, and on top of that, again, I mentioned that we are already very used to the fungi, so there is, I would say, less regulatory roadblocks if you want to basically send it. However, though, it's just in our case, sometimes even though you realize that the side stream exists, it's not as easy to convince the company to basically to let us to use their side streams and propose a solution. So I think if based on that partnership and a bigger scale, if you can tackle that uh, challenge at first is quite promising to recover this side stream and produce filamentous fungal biomass.
Okay.
Thank you so much, Miss.
Okay. Is it clear, Aurelio? Do you have another questions?
No, it's
Oh,
clear
good.
enough. Thank you.
Okay. So we are now moving the question from Nurul Hasnia in the chat box. Maybe
Yep.
the first question, I'm curious about the taste and texture of the product, as I've only heard of a few commercial versions available on the market, like corn extra. Maybe our participant is very curious about the texture and product because in Indonesia we only eat tempe, we never eat
Mhm.
the whole mycelium. So maybe Dr. Kinesi can describe us how the texture, how the taste, or the aroma, or another aspect related to the
Yep.
mycoprotein.
Of course, I would glad to share. Actually, for the texture itself, I will give. Of course, after processing, it will be different, but inherently it is less juicy if you want to compare with uh, meat in general. So it has that less juicy. As for the taste and the aroma and so on, actually, there is, I would see it as a strong point because this filamentous fungi is very neutral in taste with a very small note of earthy or umami. According to Japanese, they are strongly taste the umami. So it can actually very versatile if you want to build type of taste around it. So another flavoring will basically steal the show. For me, I see it as a good product because then, yeah, it's like empty canvas, if I would say. So there is the taste. Since we don't, and there's no much nutty taste because maybe if we compare with tempeh, because it's just the filamentous fungi itself. But I would say in general it's quite neutral. As for the texture, it's less juicy than meat, but it's kind of softer. I don't know if it's
Maybe,
explained well.
yeah, it's very interesting. Maybe you can give us imagination what meat that closer to the mycoprotein, beef or chicken meat or fish for
I would
the
say it's like, oh, sorry.
yeah.
Mhm.
You get it.
Yeah. I would say is rather like a white fish, but not so fishy, and also breast is sometimes a bit dry, like a breast of the chicken.
Okay. So maybe the
Mhm.
taste is very natural. So when we process it as a food, maybe we can still have another seasoning, right? Or just
Mm,
really on the
that's it.
natural taste. We still can have another seasoning, right? Okay.
Yep. Yeah. For instance, in here it's quite popular to have it as the filling of tacos. So they
Ah,
have this taco mix just to season it and fry it a bit and use it as taco filling.
I'm
Mhm.
very interesting to try, but yeah, here in Indonesia we don't have that. We hope that we can
Corn.
eat what's the name? Corn?
Mm-hmm.
Yeah, that the
Corn.
commercial one in the Europe, right? Maybe we can
Yep.
have it with buy it from the commercial e-commerce, maybe. I hope
Maybe you can
that's
find
right.
an Amazon. I
Okay,
don't
we
know.
move to the second question from also from Nurul Hasnia. Does the process also involve 3D printing technology or others to replicate the structure or appearance of a specific product?
Okay, that's a very nice question. But currently we are not considering 3D printing. Why is that? Because for scale up, feasibility is quite not feasible, I would say. It can change, but for now, it is not feasible to scale this up. And we want to make it like we want to make our fungi as simple as possible, and even to basically advertise it as minimally processed. And therefore, yeah, it's one of the reason too that we are not using 3D printer. But there are several companies using this for making the salmon meat replacer that to align the fibers and so on.
Okay, so it depends the companies, the companies how they want to produce the product, right? So in your
Yep.
company, they don't use 3D printing.
Yeah, it's also affected by the market acceptance. In Europe, they are quite not having a good perception of putting this ultra processed food and so on nowadays, at least.
Okay. And then we next to the third question. What do you think about the market potential of mycoprotein in developing country? For example, in my country, Indonesia, considering that Indonesia already has a wide range of affordable protein sources and their production requires advanced technology and significant investment.
Yep. There's again I say that there's a potential here because it's about if the mindset to recover the protein and to provide more food to the people, more protein to the people, or more feed to the people, not to the people, sorry, to the animal husbandries, for instance. It can be, but of course, it's to be honest, yes, it requires a lot of advanced technology and also the people, the expertise on it, the investment. Basically, it needs quite a massive movement from the system to make this establishment. I would agree on that. But however, if again, because some waste, I mean, some nutrient went into like biogas, or it's become a relative low in the nutrients recover to us again, or it's become food waste, then if you want to recover that, actually it's a quite potential. And for the scale up is, for now, I would say it's actually feasible process. It's just at the beginning, of course, you need a capital investment and technology. Sorry if it's like going down.
Oh, by the way, talking about the waste, what kind of ways that we can use that as a substrate to produce mycoprotein? In your presentation, you explain that in your company they use submerged fermentation, which is in a liquid waste. But Indonesia, maybe the waste is very diverse, especially we are an agriculture country. We have the waste from the paddy or maybe the skin of the fruits or
Mhm.
there's so many. So is it possible that we can also use the solid waste with the solid fermentation to produce the mycoprotein?
Yep. if it's say possible or not is actually possible, but again, it dependent on what is your waste. First thing first, if it's quite hard, like lignocellulose and so on, it needs some pre-treatment prior to be able to make the fungi thrive, like in tempeh, for instance. And second thing is you need to make sure that this from safety level, it is okay, because sometimes this food waste, if it's come from mixed places, then it's basically harder to assess from our point of view. The third part is, so far we used to have a solid state fermentation, but for scaling up is a bit not easy if you want to make it industrial case. But again, it's of course possible. One thing though, if you consider solid state fermentation, is like it is not only the fungi. So harvesting can be hard if you just want the mycelium, just like in tempeh case. So you need to take them as a whole. So you need to be wise in choosing what is the substrate. If you just, for instance, fruit bunch and from the oil palm, and you grow fungi on it, can you really eat it or something like that? How is the texture together with it? So there's the consideration.
Okay, it's very good. We should go to the next question from Susan. Susan, can you open your camera for a better discussion with our speakers? I will help with the question. I hope this one is not too privacy to share here. I would be able to answer. Since it's a fermentation industry, I'm curious if there is any case where the fermentation process is out of control. What kind of step that no meat industry take in that typical of case?
That's a good question. Of course, we also experience a lot of this process out of control. I will try not to explain too much since I'm also banned with the contract. so, so I'm being very
Cannot share
careful
all.
behind that. Yeah. So as I mentioned, it has a macro structure, right? That is can be the source our failure. Like in the conventional submerged fermentation, you have a certain graph or certain way to know what is the where is the position of this fermentation right now. But apparently in filamentous fungi, oftentimes the morphology itself it's very sensitive sometimes, and it can lead to the failure. And we try to map out for one month or 1 week, depends on the cause, on why. For instance, we designed it to make a dispersed mycelium, but suddenly it's like, oh, I'm not in the mode, I will go to the pellet mode. It will change the hydrodynamic in the bioreactor, lead to the failure, and then we set this spin, oh no, the sparger and the mixing certain, yeah, but at the certain level. But then when it change morphology, then hydrodynamic change, it can be like too fast, breaking down all of them, or it can be becoming, oh, it's not enough, now increase me or something like that. If it's not enough, it's dead. If it's too much, it's also dead. So that is one example. So morphology is one of the challenge for us, but I cannot go into detail on that. The second part is, of course, contamination is a classic things happening. Since we are also taking the side stream, for instance, from dairy company, from a vegetable processing company, that inherently sometimes it has its indigenous microbes there, even though we go through fermentation, but our surrounding might be like have some splash of this side stream. So there is one thing.
There any another explanation, Dr. Ignacy, or it's enough? Or maybe from Susan, do you wanna uh, have another question to make it more clear? Is it enough for you, Susan? I know it's you know it's industrial privacy, so maybe our speaker cannot explain all the secrets.
That's
I
fine,
hope.
sir. Thank you.
Okay. So we move to the next question. Sarah Salihu, she has two questions. Maybe we start with the first question. Please, I want to know if the meat replacer is cost efficient compared to production of all other protein sources. Yeah, it's very interesting question. Is it more worth it to consume mycoprotein or animals protein or plant proteins? Yeah, it's very yeah, insightful if you can share with us.
Yep. So again, this is still prototype, and I would say by comparing with what we have now, actually for cost efficient, it can be yes, because we are using side streams. Unlike I don't mind to use corn for this, but they are using quite a synthetic medium that is derived from plants and so on. So they are using a lot of cost to provide this substrate. And that is how, in our case, it is quite economically feasible because of this side stream, thanks to that. So it's for now it's comparable for other protein source, because if we talk about Norway, protein source is super expensive. To be honest, now I can only afford eggs. No, I'm joking, but chicken is quite expensive. Everything is expensive, so it's quite comparable, reasonable price. I would like to add another dimension on it. Of course, we also need to talk about the bioavailability of the amino acid when we compare, because we label it as mycoprotein, right? But we have in here, of course, we have less lipids and then also quite the fibers. So for the food of choice, we can actually label it as more wise for nutritional value. And the second thing that is big is actually not only about the economic. People here also care about carbon footprint. For a picture, again, we have lower than 3. In our most optimized, we can reach 1 or even 0.8 per kilogram product. And as a comparison, for instance, meat, another meat, beef is having 99 compared to us. So people are attracted to this too, outside from the only about the cost.
Okay, maybe next to the next question. Is the nutritional value of corn high compared to other sources of protein, and is it time saving in terms of production? How long does a production cycle take, and can it be scalable?
So yeah, I will be careful answering this because
Because it is no problem
corn is
another
not
company.
yeah, it's not my company, first thing first. So of course their claim is they have a fair amount of protein. It's comparable with the stuff around type of other proteins, I would say. And for time saving in production, how does production cycle take, and can it be scalable? In our case, we are trying to scale up. Our model say it is scalable, so I hope it is. It's as long for production cycle, I couldn't say that. Basically, it's still a secret for us. But if it's not efficient, then we will not scale this up. Basically, that is the main take. But for corn, I'm not sure. I cannot answer on their behalf.
Okay, we understand that. So maybe Sarah Salihu, is the question already answered clearly, or do you still have another question to make it more clear? Please let me know as your sound is not sounds clearly, or maybe for another participant that still have a question, maybe from student here that as participants, Nomi also give the chance to do the internship. Maybe you can also ask about internship here.
Yep, that would be interesting.
Maybe while we waiting for another question, maybe I would like some question to Dr. Kiranti. I wonder what species that we can reuse as a mycoprotein producer, and also I still don't I don't know, is it also possible? We already know mushroom, how to go uh enoki mushroom, is it also can be called as mycoprotein since it also mushroom, right?
Yep. I would say it's also mycoprotein is a mushroom. Mushroom is mycoprotein. It's just they have fruiting body. They are taking maybe they are not the mycelium. It's the mushroom itself.
Ah,
I need to check. I need to check it. This is a bit tricky, but yeah, because my mycoprotein maybe derived from mycelium, but myco.
mm,
Mm-hmm. That is a good question. I have to check about that. As for the
okay.
species, yeah, I cannot say for detail, but I would suggest if you have an idea or something, go with the one that is already generally recognized as safe. It's just save a lot of time.
We can Indonesia, maybe we can use rhizopus for tempe also can produce
Exactly.
mycoprotein. But is it possible also to produce mycoprotein of a single strain? When we ferment to produce a mycoprotein, is it also we use the starter culture with the mixture of a lot of spore of fungi, maybe not only rhizopus, maybe another spore that safe to be consumed. Is it also possible?
Yeah, that's a good question. Coming again, yeah, it's called co-culturing.
Yeah,
Uh, it's also possible, but for now we are actually go with a single strain for now because of the complication coming from the side stream itself, and we decided to lock it first. And of course, it is part of our R&D to see if actually co-culturing will be more beneficial for the both the process and the product resulted like in tempo. It's like
What is the
if you. Mhm.
what is the challenge that we use co-culture to produce mycoprotein? Maybe from the morphology, maybe? Is it also
Uh,
possible?
Yeah, the morphology can also be because it's affected on what is the condition, right? What triggers their morphology can be different. Like they have, for instance, they have the same experience of nutrients, but one cannot tolerate it, and then they change morphology. That is one thing. The second thing is the different growth or doubling time. So one can be more like let's say greedy than the others in certain circumstance. They deplete all the nutrients and the other just grows slowly and in the end might inhibit the other one. For instance, those type of things like different pace and different characteristic. And we need to see like in the nature how they grow together. We need to mimic on what is actually make them can work together. That's also the key.
Yeah. Wow. Actually, we have one question again from Rati Paramastuti. How to
Mhm.
make sure the fungal strain is not toxic?
Yep, that's also a good. That's a good question. So, from the beginning, from the strain collection, so of course we check our strain collection that we bought somewhere in culture collection. We need to make sure that we are not ordering or having the fungi that actually mycoprotein producer. So we choose the fungi that is already declared to be safe. But as our fungal microbiologists say that we never trust the culture, so collection. So we need to have our own quality control. Then we just basically first you can do the sequencing on it to make sure that it is really this funga. And if it's really this funga, then we are feel assured about it. On the other hand, we always need to test for now, like the mycotoxin level on our product, for instance, and what trigger it's. If we know, oh, this condition will trigger mycotoxin for real, and then we collect the sample, and then we check whether internally or ship it to another company to check, is it containing mycotoxin?
Okay, it's very interesting. We have one question. What role does corn play in promoting sustainable food system globally? Actually, the question is more corn that
Or what?
not your home base of industry. Maybe you can answer as your confidence.
Yeah, I will just answer briefly as I know. I'm not sure if it is sustainable food, but they always have this carbon footprint in every of their product. If I can give example, like how many carbons. So basically they promote that this is like mindful eating. If you choose corn, that is what they are promoting. Mindful eating for nutritional value and mindful eating for the environmental impact. So they say that the production is basically less damaging for environment compared to another source of protein. But that is what I capture from corn.
Okay, we still have some times. Maybe there is still some question from our participant that has been not delivered. Or maybe, Dr. Ginanti, you have the time to deliver more about your internship. I believe our student very excited with the internship over there on NOMI, but they maybe too shy to ask.
Yes, that's fine. So again, about this internship, maybe it's better to give also example on one of internship we have, what of intern. So here we have Alex. She's from France. For instance, she is contacting us at Career at NOMI, and her major is actually environmental engineering. So this is the type of maybe how to approach us. She come to say hi and then sending like a short motivational letter on why you are interested to do a internship with us. Or if you have already an idea of what you are doing, you can just contact us and we can communicate on the possible project. Before we also have even the intern for the design from design student. If you see this and this, let's say mycelium and spores connect to each other is also from the design students. So not don't be too worried about your major and specification. It's fine. Just the first thing first is just contact us that you are interested. And from what I have explained, maybe I can explain the hotspot again on what is currently our work. Of course, this spectral analysis, we are still developing more and more modules on that. So if you are interested or have expertise in chemistry or instruments, analytical instruments, even mathematic modelings or so on, you can have definitely a work in this to work with our senior data scientists. And then in the media itself, if you are having the fermentation, if you have a microbiology background, you want to learn more or you want to contribute about this filamentous fungi, it's also a spot. We have a seed training. And media fermentation, media supplementation, and so on is mostly, again, it can be many things, biology, environmental engineering. This is quite wide as long as you're familiar with these chemical compounds and characteristic. And bioengineering is one of the field that is very extensively needed for us. So it doesn't have to be bioengineer, but even engineer in general, you're also very welcome if you want to be here for agricultural student and so on. Since you're also familiar maybe with your agricultural waste, seasonality or something, then you can also contribute on that. Food scientist, yes, but mostly you will work with me. So it's like developing product characterization. Mostly for now is regulatory. If you're interested about Europe regulatory and food system, just also just give it a shot and contact me directly. So
Yeah,
that is
we have another participant who very interested to join you. Maybe I've also worked on fungus, but I got great information from you later. Is there opportunity connect you to work on fungus? You can connect with Dr. Kin by the email on the
Yep.
screen, Mr.
Yes.
Muhammad Supra.
Yep. Send your CV and motivational later or just self-introduction. It's totally.
Okay, we have one new question from Rati Paramastuti. Can you give the
Mhm.
example of side stream source for fungal growth media? Is it possible to use the liquid waste from tofu fermentation?
Yep. So, for examples, I think the easiest maybe since we work with Nitin, something like their side stream molasses or some, yeah, I guess it's like a molasses or sucrose byproduct. And other thing is dairy product, dairy byproduct. For instance, like the permeate whey or something. And for example, is tofu. Sorry, I'm a bit lost. Liquid waste from tofu fermentation. That's also very possible. So it is a really basically we need to know the composition first. As long as it's contain fair enough amount of carbon source. I would say carbon source is the most important parameters. And what type of carbon source, then we'll see it as possible. Even like a protein, like amino acid is also possible, depend on what type of fungi.
Okay, so it's very possible to use liquid waste from tofu fermentation as a medium to produce mycoprotein, since it's
Yep,
maybe still have some nutrient that can be used by the
yep,
fungus.
yep. I think
Okay,
it's like
we
Mhm.
okay. We have new question. I'm curious about the fermentation process in the reactor. Does the fungus grow on the surface of the solution or how?
Yes, it is growing in the surface too, since inherently it is aerobic. But for the solution, I will not go to the detail because it will be patented.
It's okay. It's okay, Doctor.
Yeah, I'm
We
trying to
understand
be
that.
open. Yeah. Yeah.
So it's growing on the surface, but when we use the reactor, we also use the spindle, right, to aid the aeration. Is
Yeah.
it possible to the mycelia to have the clock on the spindle?
Most of the time it's not the case because we calculate the tip speed in order to avoid that, uh, to make sure
Uh,
that the shear stress around is
mhm.
going, and also the type of the, which is also a secret. We have the type
Okay,
of.
maybe we wait some question again. I would like I would like to ask what else? Maybe all the participants that still have a question, this is the best chance to you to deliver your question because I think it's very new knowledge related that we have a source of protein that are also from animals and plant, but we can also have the protein from mold or from fungus that we used to eat as a tempeh. But there in a Europe, they produce the fungus itself and eat the whole fungus as the source of protein. Maybe is there any question left? Okay, maybe there is no question. Maybe Dr. Kinanti, do you wanna have a take-home message from your course to our
Mm,
participants?
uh, yes, just a quick, this might be a new area and new expertises are needed here, but it's not totally new. So you can basically work together like the mycelium trait. It's what we are using. We work together actually to basically connect our expertise to tackle this type of challenge and solution we want. So yeah, if you are interested, just be confident and so on because it is a good opportunity. It's not always about to sell the product or the fungi, but also to recover the protein. This filamentous fungi is, at least as an Indonesian, what I first think of is I always think this filamentous fungi limited as my foods only. But I realized when I joined this company that it can be more than our food. It can also recover what's supposed to be still be our food. So be confident, and if you need to support and so on in this, if you want to hone the knowledge on this, if you want to gain experience on this, just let us know and contact us. It's we efficient to spread it like mycelium too. It's not like we want to keep it. We want to try to first have a feasible process, and then we want to share it with around the world. For example, we went to Japan too. So
Okay, maybe Dr. Ken, is it possible if some participant contact you through the emails? Maybe they still have a questions that now cannot deliver here. Is it possible?
yeah, sure.
Yeah.
I will try my best to answer.
Okay, so because there is no question, once again, thank you to Dr. Kinanti for delivering a new insight for us that actually we not only can get protein from animals and plant, but we also can have protein from fungus. That the production use the side stream, so it's very new for us. I hope that this is, even though the new areas, we can explore more. Not oh, actually, we have the new question. The last question
Nice.
before I officially closing, guys. So we would like to know the popularity of microprotein in Europe or compared to Asia. So that will be the last question before I officially close this session.
Yeah. Yeah, the popularity is, I would say, quite fair. I would give an example of other type of protein, like from spirulina is also available, and then also another plant proteins. But nowadays, aside from corn, it's gaining popularity because naturally it has this power of texture that it require minimal modification on its, so it has a good image of being not too ultra processed compared to another plant type of protein, at least in Europe. I'm speaking about it because now in Sweden and in Norway, they are concerning about, okay, we have alternative protein, but since we try our best to mimic the conventional protein, in the end, it's become ultra processed food, and it can damage the reputation of it. But as for fungi, it's quite, the acceptance is higher compared to insect that now is not scalable because of people acceptance is low. And the other thing is because they are require not so many processing in order to meet to be similar with the other protein content protein conventional protein.
Okay, that will be our last question. So for our participants, Dr. Kinanti, don't mind that you can deliver your question through the emails. So if you don't have chance to deliver your question right now, you can just email the Dr. Kinanti and she will answer your questions. Once again, thank you, Dr. Kinanti, for
Yeah,
your
thank you.
insightful courses related to the mycoprotein, related to your industry, and etc. I hope that we can meet again in person, not in a desktop size. So yeah, thank you once again, Dr. Kinanti. So for the time,
Thank
I
you.
give back to the MC.
Yeah, thank you for the opportunity.
We want more lectures.
Thank you to all participants for your lot interesting questions and active involvement. I think all participants are very interested in today's material. Okay, on behalf of the committee, we extend our deepest appreciation to Ms. Kunanti Modilaksita PhD for sharing his expertise, and to Dr. Ramli Kamil for moderating today's session. Okay, let's give them both a warm round of applause. Okay, before we officially close, don't forget to fill in the attendance and feedback form. And don't forget And I kindly remind that summer course program will be continued tomorrow at 8:30 p.m. Okay. That concludes our session for today. Thank you for your participation, enthusiasm, and commitment to learning. We wish you a productive and enjoyable day ahead. I am Yanjana Koima. See you at the next session and have a great day. Thank you.
Thank you. I hope to see you again. Bye bye.